Okay, Assalamualaikum warahmatullahi wabarakatuh. I'm Manuddin Soleh Hamid Awang from group number 2. So I will discuss about question number 1. So first is question number 1, 1 Roman. So we are given these two equation, which is ST and HT. So we need to do the convolution. So this is the convolution definition, which is from this definition we substitute the information given, and then we got this one. So we find the limit, which is from u t minus 1 we got tau greater than 1, and then u t minus tau we got tau less than t. So from this we can simplify the limit. So we got the limit is 1 until t. So from this we simplified it, and then we got this integral. So after we simplify and evaluate the all integral, so we got this answer, which is the convolution of between xt and ht. And then this is the graph will looks like after we convolution between this graph and this graph. Okay, for the question 1 to Roman, we are given this xt is equal to 3 cos 2t and ht is equal to exponent negative t. So we change into this form to see the limit. Okay, and then we substitute into the convolution form. I mean it's convolution integral. So we break into cases, into two cases. So therefore we got these two, and we need to solve this in Laplace transform. So we need to use the Laplace transform. So from this integral, so we change it to the Laplace transform, and then we solve the Laplace transform from the this equation. So for Laplace transform of st, which is cos 2t, we got s over s squared plus 4, and then the answer is this is after we Laplace transform, and then we Laplace transform exponents to the power of negative t, then we got this. So we do the partial fractions, and then after we got this, we do the partial fraction and to find the a, b and c. So after we arrange this one, we will get this one, and arrange every equation, every terms, and then we got a is equal to negative 1, b is equal to 0, and c is equal to 1. So from this we substitute back into the equation, then we got this equation. So we do Laplace transform of this one and this one. So after we got Laplace transform, then we got the answer, which is this one. So this is the answer for the question number 1 to Romans. Number 2, so we need to use the MATLAB for the convolution of f1t and f2t at t is equal to 0 and t is equal to 1. So we need to sketch it using the MATLAB. So this is the coding from the MATLAB that I use. So this the result that I get from the MATLAB. So this is the f1, and this is f2. So this is f2t is equal to at t is equal to 0, and then f2t at t is equal to 1, and the last one is the convolution of f1 and f2. So we got this signal. Okay, that's all from me. Thank you.
My name is Pugalindan Ganesan, and this is for question 3. The question 3 asks us to obtain the convolution of the two signals and also sketch the signals for each case using MATLAB. So our task is to compute the convolution of two signals first using mathematical solutions. So xt is a unit step function defined as 1 for t greater or equal to 0 and 0 otherwise. Ht is a triangular signal defined piecewise, and the convolution formula is as stated below. Yt is equal to the integration of x tau times with ht minus tau d tau, and the limits are infinity to negative infinity. The convolution integral that we discussed in previous slide is solved analytically by splitting yt into four distinct cases based on the value of t. Here in this slide we can see two cases. First case is t less than -2 and there is no overlap, so yt is equal to 0. And the second case, -2 less or equal to t and t less than 0, overlap occurs in the ramp section ht minus tau. So when we solve the integral, we can get 3 over 2 in bracket 3 plus 2 t plus 2 to the power of 2. Next, we are going to see the case 3 and case 4. In case 3, the overlap occurs in the constant section of ht minus tau. The convolution result is y is equal to 2t as shown in the graph, that is the overlapping region. And in case 4, t greater or equal to 2, there is no overlap, so yt is equal to 0. And we can see the final answer for the yt, the convolution from the convolution integration. Yt is equal to 0 when t less than -2, and there is a quadratic function 3 over 2 in bracket 3 plus 2 to the power of 2, then and the region is bounded in between -2 and 0. And next is 2t and the region is between 0 and 2, and the next one is 0 for greater or equal to 2. Using MATLAB, we have computed and plotted xt, ht and their convolution yt. Here are the results. Here we can see the coding that has done to get the results. First, we define the time vector t ranging from -t to 6 with a step size of 0.01 for xt and ht. Xt, we define it as a unit step function, and ht as a piecewise defined triangular signal. The convolution is computed using MATLAB's built-in conv function. The result is scaled by the time step dt is equal to 0.01 to approximate integration in discrete form. Finally, the code generates 3 plots to visualize xt, ht and yt. In this slide, we will discuss the generated plots by the MATLAB code. The top plot is xt, a unit step function starting at t equal to 0, and the middle plot is ht, which consists of a ramp increasing linearly from -2 to 0, and then a constant value of 2 from 0 to 2, and then a 0 outside this range. The bottom plot displays the convolution yt, where yt is equal to 0 for t less than -2 and t greater than 2 due to no overlap, that we have discussed during the mathematical calculation. Yt increases quadratically as 3 over 2 in bracket 3 plus 2 to the power of 2 for negative 2 less or equal to t or less than 0. In other words, the region bounded by negative 2 till 0. And then yt grows linearly as 2t for the region between 0 to 2. These results match the analytical solution perfectly and verifying its accuracy.
Okay, Assalamualaikum and good morning. So my name is Haziq and I will explain about question number 4. So the question number 4 asks us to find the overall impulse response HT of the system shown in figure 4. Then use MATLAB to sketch the impulse response HT. So we have H1t equals to 3 delta and H2 equals to 2 exponent negative t ut and H3t equals to 4 exponent negative 2 t ut and H4t equals to exponent negative t ut. So all these responses are connected as shown in the diagram. So after deriving HT, we need to use MATLAB to plot the impulse response graph. So based on the figure, the system has two branches and we analyze them separately. So for branch 1, H3T convolved with H4T. So the formula of the convolution is given by HT integrate infinity with negative infinity and H1 T multiplied by H2 bracket T minus theta in bracket d theta. So to find the overall impulse response, we have to add H branch 1T plus H branch 2T. So let's move on. So this is the answer. So for H branch 1T, we have to use the formula like this shown. H3T will multiply by H4T. So we sub in and then we do the calculation. As shown, for the H branch 1T, we get 4 in bracket exponent negative 2t minus exponent negative 3t, and for H branch 2t we get 6 exponent negative t ut. So to find the overall impulse response, we have to add it. So the HT is 6 exponent negative t plus 4 exponent negative 2t minus 4 exponent negative 3t. So let's move on to the MATLAB. So here is the working of the MATLAB that I have done. So let's go dive into the coding. So the coding is this coding defines the time t from 0 to 5 seconds and calculates the component of the overall response impulse of the HT based on the equation that we derive. So the final plot um, is shown next on the slide. So here is the slide generated by the MATLAB. So this graph is a combination of the three exponential terms of e negative t and e negative 2t and exponent negative 3t. So the 6 exponent negative t term dominates initially because its decay is slower, and for the 4 exponent negative 2t and 4 exponent negative 3t terms, it contributes more as time progresses, causing the curves to flatten. So at t equals to 0, which is the initial, the ht is at its maximum because all exponential components will contribute to their peak value. So as t increases, the response ht approaches 0 due to the exponential decay of all terms. So that's all from me. Thank you.
Assalamualaikum. Now we will do for the question 5, which is perform the discrete time convolution for n equal to 3. We have given f1 n equal to n u in bracket n, and f2 1 over 3 power of n un. And then first, to perform for our question, first we have to mathematically. For for number 1, for the convolution formula we have given for the causal discrete time signal is which f1, which means f1 equal to f equal to 1 is greater than 0, and f2 1 over 3 power of n, which is greater or equal to 0. And then we substitute the convolution sum, which is n equal to 3, and then we substitute the value into 3 here, and then we get the value, and then we get the then we compute term by term, then we get the answer, which is y equal to 3 equal to 34 over 9. Then we do the second question, which is the graphically. We do by manual first. At first, we flip f2k horizontal about k equal to 0 to get the f negative k, and then we shift f negative k by n, resulting f n minus k, which the n number 3 we multiply f1 k and f n minus k by point for each k and 3, and then we do the summation of the product to get the valid k. This is the graph by manual counting. This is the manual table representation, which n equal to 3. We have k, f1, f2, and f times f2. This is the summation of f1 and f2. This is the graph for the f1. This is graph for f2. This is the graph for the signal shifted f2. And this is the last graph, which is f1 and f2 by multiplying point to point. Then for the question 3, which is the MATLAB, we have done the coding. This is the coding. First, we do the MATLAB code for the discrete time convolution, and then we define the range of n here, and then we define of f1, and we define f2, and then we compute the convolution, and then we select n equal to 3, and then we select the required value at n equal to 3, and then we display the results. Let's run the code to get the graph. This is the code that for the question number 5, Roman 3. That's all. Thank you.